Hello, I'm Mihal. This is the product overview for Group 1. Our website is the AutoEngineers. Essentially, we're an Amazon.com, but only for car parts. Some of our core functionalities include ability for users to purchase products through the online store, member accounts which give benefits such as discount codes, ability to make appointments for on-site repair/tuning services, and abilities to make returns on orders. So the subgroup I worked on was subgroup 1, database management. The contributors for the subgroup are me, Nihal Abdulnir, Henry Spriggle, and Thomas Vu. The use cases we've implemented for this demo are the following. Uh, Admins can web scrape to initialize the product database. Admins can add, edit, and delete products in the product database. Admins can add, edit, and delete members in the member database. The member database also has password encryption implemented, and admins can add, delete, and edit discounts and transaction databases as well. We collaborated pretty closely with the other subgroups to do this. So the product database we created was forwarded to subgroup 2 shell functionality so that they could implement it with their cart functions. The member database was forwarded to subgroup 4 member services so that they could implement it with their login functionalities. This is a workflow for one of the use cases that was implemented, which is that an admin can remove a product from the product database. So in this workflow, what happens is the admin web scrapes, initialize the products to the product database, and then access the database to delete the product. So firstly, the web scraping works is we scraped from the websites of Bullet Automotive and Discount Tires to get all the data. And to do this, we set up the scraper using Selenium and used the Chrome driver to access several different pages on the two sites. This was done in a very modular manner. And the data accessed was filtered by CSS class and formatted. Then all the data was consolidated into a single array and written to a text file. On the right is what the output of this text file looks like. Once the text file was written, it was then passed through into a product database so that the product data could be initialized to it. During this step was also when the inputs were verified. So any of the products with invalid inputs would not have been entered into the database here. After this, the delete function was implemented so that the admin could delete the product from the product database given its product ID, thus completing the use case. Other functions were also implemented, such as post and put, but those are not shown here right now.
Okay, now here we have the database.js file where we can show how the post, put, and delete functions work for admins in the member database, where it verifies inputs. So here is verification of the post working, where the member is registered successfully and it outputs your member ID. And then we can show that the put works, where it will update successfully the member and then output the member ID that was updated. And finally, we have the delete function being shown to work, where the member is deleted successfully and the member ID is then shown.
Here we have the function that actually encrypts the passwords. It takes in the plain text password and a salt. If the salt is not defined, then it generates its own salt, and then and it uses SHA-256, which iterates 100,000 times in order to encrypt the password, and outputs an array of the hash password and the salt that was used for the encryption.
And before we move on to the next subgroup, I want to quickly mention that the first two use cases were implemented by me, Nihal. The second use case was implemented by Henry. The last two were implemented by Tom.
This is the subgroup 2 work. I'm Noah Jacobson, and I did the general format for the API, which other people based their work on. I made the add, remove, and update functions, as well as the cancel place with little functions. I did some work on creating and removing appointments, and I refined the search and browse functions. Leo also worked on the auto functions, as well as making the encryption algorithm and working on the appointment function. And Sahaz made the search and browse functions and reviewed our work for bugs. Now we go on to the order operations. At first, the list of orders is empty. And then we go to Postman and add an order. And then you see one here. We can also cancel orders with the cancel function. As you can see, it's pending here, but if I reload, it's canceled. We can also list all the orders belonging to a certain member with the list function, as seen here. It matches. We can also get the details of one of the orders using the order ID and the details function, as you see here. At first, in the appointments, we don't have any, but then we can add an appointment, as you see here. We can also cancel an appointment, as seen here, the specification turns to canceled. For our database of products, we're using this set developed by Nihar with around 2,000 products. So it's initializing with a product ID of 16 numbers, a type, a name, a price, and a quantity. So it's finished, as you can see here. Then we can add an item to the cart with the add function, and it's visible here. If we want to change the quantity of a product we have, we use the update function, which adds some, as you see here. We can also clear a cart with the clear function, which removes all products belonging to one cart. We also have a search function developed by Sahaj that can find products by their name. So this contains all the products that have bumper in the name. Sahaj also made a browser that can get the name of a product based on its product ID.
Right, now moving on to ticketing. Our group is responsible for customer service functionality, and we chose to develop the use case of tickets. We've included options for creating tickets, add replying tickets, closing tickets, and a general FAQ page. The general layout of how we accomplish this is above. We created two tables in our database, one to hold user ticket info and another to hold reply ticket info. FAQ is free floating because it's available to everyone and doesn't connect to any external methods. And just to go over FAQ real quick, we've developed our frequently asked questions page by web scraping from Discount Tire. We decided to scrape from here as we also got some of our catalog items from Discount Tire, so we figured that their FAQ would closely match what we want in ours. We use the Selenium WebDriver and Chrome WebDriver to aid in this process as well. When that was done, we tweaked the text to make it fit our needs, such as changing Discount Tire to our business name, AutoEngineers. Finally, we took the text file and connected it to the function getFAQs within ticketcontroller.js, as Rick will go into later.
This is the function that API call that responds with that. So I'll be using Postman as a front end UI for us to look at the APIs, and then DB browser to look at the specific two tables that are being called upon. So let's look at the methods. First of all, we are able to create tickets within our program. So to do that, we have to do ticket-create in the post method. So let's go ahead and create one. And here, we do this address. Sorry, after we start the server first, and we go into the address, body, and we type in our things that we want. So for example, my user ID is going to be 39 in this case. My subject is demo test 1. And my description will be this is a test for demo test 1. And let's just run it. And then here, you can see that a new one has been created, ticket ID of 10 with a user ID of 10, and it is currently open. Now to the next one, the replies. To reply, we simply type this in the address, and then the body, we have three things: the ticket ID, user ID, and then reply. So let's go over ticket ID. Ticket ID of 10, and the user ID of 39. And let's send it. And this will appear in the reply section. And as you can see here, 39, ticket ID here, and reply of 14. The admin, other members, however, such as a user ID of 40, will not be able to reply because they do not have permission. Only the original user and the admin, which has a user ID of -1, will be able to reply. See, 15. Next one. Ticket details. We go here, and we have two inputs: the ticket ID and the user ID. So if we were to look at our previous one of ticket ID 10 with a user ID of -1, which is the admin, we'll be able to see it, and we can see the ticket ID as well as the information about the replies. If it's something that does not have permission, we will see that you do not have permission. And if we have 39, you can see that we will have permission to access it. Now same thing with, now we go into our function of close and open. All you have to do is type in the user ID here, which is 10, and the user ID of an admin or the original, the admin, and we can close these. Ticket successfully closed. And here you can see that this is now closed. Now we can open it as well with the user ID, and it is now successfully opened. However, we cannot close it with somebody who does not have access to it, such as 393. Do not have permission. That is the end of this demo. Thank you so much.
This is subgroup 4 of group 1, and we're responsible for member services. My name is Christian.
My name is Abid.
My name is Joel.
In this demo, we're going to cover the following use cases: login functionality, third-party login, and membership deletion. Then we're going to cover appointment scheduling and service request cases. And then finally, we're going to cover discount and warranty cases. We're going to start with Joel.
I'm covering the login functionality and third-party login and membership deletion cases of this group. This code was written originally by Henry in subgroup 1, which covers the databases, and I used this code to to handle my use cases with the third-party login functionality. This code sets up an HTTP server that handles authentication via Google and Facebook, Auth2 services, membership registration, update, and deletion. For Google authentication, it verifies tokens received at the callback URL and fetches user information from the database based on the Google user ID. And the same thing for Facebook, it grabs the token and then redirects the users to Facebook's authentication page, and then it sets the user information. Member registration involves validation of input data, generation of unique member IDs, and insertion of member details into an SQLite database, while member update and deletion functionalities modify and remove member records based on provided member IDs respectively. Now I'll be going to Postman to show in some client requests based on the code. Here we have the path to Google. When a client clicks to log in with Google, it'll send this, and it will redirect us to the login screen, to the sign-in screen for Google. Next, we have a regular sign-up sheet with the membership path. We have a username, password, phone number, and admin status set up as here, and a membership registered successfully with this following membership ID. And next, if we want to delete a member, we select a delete request with the following path, and we run that, and we have the membership deleted successfully with the following membership ID. Next, we'll be going to Christian.
In this Node.js service script, we have an appointment scheduling system with 4 main functionalities that highlight the appointment scheduling and service request cases. Users can create appointments by sending a post request to /appointment, providing required parameters like member ID, date, and service type, which are then stored in the appointments database. Similarly, service requests can be submitted via a post request to /service request, and the server generates a unique ID and stores the request in the service request database. Appointments can be canceled by sending the delete request to the /appointment /ID, where ID represents the appointment ID, updating the appointment status to canceled. Additionally, appointments can be postponed by sending a put request to /appointment /ID with action equals postpone and a datetime parameter indicating a new appointment time, modifying the appointment accordingly. The rest of the code highlights how to create a server that runs on port 3005. And then now we're going to go to Postman to show 2 examples of 2 client requests. The first one is going to be a post where we create an appointment. As you can see, you have member ID, date time, and service type. And when we run it, you can see that it runs correctly and outputs the status code to be 200. And then we're going to go to the other example, which is delete appointment, where members can cancel their appointment. And when we run this one, you can see that it also runs correctly and outputs the status code of 200. And then finally, we're going to move to Abid to talk about the rest of the use cases.
So I am covering warranties and discount cases. So this code sets up an HTTP server using Node.js to handle CRUD operations for discounts and warranties. It interacts with a SQLite database to store and retrieve data. The server listens on port 3000 and handles incoming post, put, and delete requests for creating, updating, and deleting entries in the database. It ensures data validation, generates unique entry IDs, and responds to requests appropriately. So overall, it provides a basic RESTful API for managing discount and warranty information. So now we'll go to Postman to show the discount and warranty request. So the first one is for the discount entry. So as you can see, we have the name, description, duration. So when it's successfully ran, the client will see that the entry was registered successfully, and you'll also have an entry ID generated. And the same thing will go for the warranty entry. You'll have name, description, duration, and the same message the client will see. So overall, the requests stimulate the process of adding new entries for discounts and warranties in the system. The provided data ensures that the entries are properly formatted and meet the necessary requirements outlined in the overall code.